Our next speaker is Jaren Haber, who is a doctoral candidate in sociology and a member of the TextXD organizing committee. You're seeing a theme here. Who's going to be talking about creating dictionaries and tuning dictionaries using word embeddings.
Hi, everybody. How you doing? Oh, lame. How are you doing? Oh, yeah, that's data science enthusiasm. I like to mine that as much as possible. Mind the text and mind the people. That's my motto. OK, so my text is bold because I find this very exciting. This is kind of an accidental byproduct of my dissertation, which was accidentally about text analysis, and now is like, what the hell do I do with this text data? I need to develop a new method. So we're doing that, actually. And a lot of other people are, too. There's really good work in this direction. Really happy Bart's in the audience to, we're having a conversation about this. So, right. This is meant to be a method that's inspiring to you and you can take and use in other places. And also, I really appreciate criticism. So I'm not going to talk the full 20, so save up some questions. All right, so the whole goal is to make better dictionaries. What's a dictionary? It's a list of terms that are centered under one conceptual umbrella. It's a pretty intuitive definition. It's usually what we mean, but social scientists have been using these for decades to calculate all kinds of things about people, political attitudes, psychology, and there's this whole burgeoning field right now of sentiment analysis and social media data that most of you, I'm sure, are aware of, and we're talking about it here. So yeah, where do these dictionaries come from, these lists of terms that we use to calculate things about people? And in my case, I'm trying to learn something about charter schools and how they talk about education, who they're trying to appeal to, and there's no good dictionaries on that. So how do you build something like this when there's not really good research to back it up in? OK, so most of the time the dictionaries that people do use are either idiosyncratic, they come from a particular field and they read a bunch of papers, or they use some expert knowledge to develop this dictionary. Not that valid in my opinion, so I have a better option to propose, and it's building on some other research here. You start with some core words, some gold standard, a couple of concepts that you're interested in. You only need a couple of words actually for this to work. You expand them inductively using a word embedding model, which I'll get to, and then you validate it. Sounds simple, right? And there's a couple of different steps for validation. I'll get to that too. The benefits of approaching it this way, having a list of terms that you've created and then you're then using to count something about some kind of entity that produces text, like an organization, could be a school, a company. Well, all kinds of people produce, like websites are ubiquitous, obviously, right? So you could learn about pretty much any kind of entity by looking at its text and just counting the occurrence of certain kinds of words. So that's why it's accessible. It should be pretty intuitive. Even people that are not computationally inclined can follow that idea. Also, this approach is reproducible. The code's online and can be validated. Right, so in my case, I'm using US charter school websites. And I'm looking for two themes. And to tell you the truth, I started with one. I started with inquiry-based learning because it's controversial in the learning literature. And I thought would distinguish different kinds of schools from different class and race communities. And then I actually induced the second one. So I'll kind of spell that out for you. But basically, that's what you need to know. I'm not even going to say too much about what these are. Yeah, I'll just leave it there. Move on to the next part, which is more exciting. So how do I do this? It's a short talk, so I'm just going to focus on that. But sorry, first, let me show you some data. This is data. KIP. Raise your hand if you've heard of KIP. Oh, come on, you're being shy. Oh, really? OK. Well, this Knowledge is Power program, it's one of the most distinguishable sort of like traditional focused or high discipline sort of programs. Has a great track record of taking kids from disadvantaged communities and backgrounds and kicking them into college and even helping them get through college. So it's, it's an example of that sort of approach. And here's a watercolor painting. They probably do something differently, I'm guessing. So, and also look at different kinds of text in different places. Look at this one. Notice what kinds of text is on that front page there. One more. One more. And these are all completely inconsistent. Web scraping is another talk. OK. Anyway, so how do I do this? The basic method is actually training my own word embedding model, which requires a good amount of data, which is one limitation on the approach I'm proposing to you. But anyway, it's really awesome. And potentially you could do this with pre-trained data that you then just expand using some kind of text. It's not quite as robust as what I have. But word embedding lets you do things like this. You can start with a couple of concepts. Those of you that were in the workshop yesterday, this should look really familiar. Even just a couple of words here. And the distance from king to man actually captures the effect of royalty. You're getting a concept latent in the language itself just by training a model on the semantic context of language and cleaning and repeating that. I'm not going to get into details. The idea is king minus man is the effect of royalty. Some funky vector over there, and that's the same one that distinguishes woman from queen. I think that's pretty profound. You don't need to have the computer understand anything about what language means, but you feed it a big string of words in order, and it's able to understand something about the intersecting relations and cultural context of the language that we use. That's amazing. What else do I do? Well, okay, the big things here, I'm going to talk about are coherence and distinctiveness. I'm just going to say, know what those are, and I'm going to actually explain them to you in a moment. So just to get you thinking, I use visualization with TSNE. Pretty, it's not that old of a package, but it's pretty established at this point. And its basic method is to embed high-dimensional vector space to 2 dimensions through conditional probabilities. Really cool math. Look it up. I'm not going to waste time on that. The other thing I do, which is even newer, HDB scan came out, I think, last year. Hierarchical, density-based clustering algorithm. What's the N mean again? I have that on my notes here. Something. Scroll down. Nebulous. I can't find it in my notes here. Oh yeah, with noise. Actually, that's important. The noise part is important. Okay, sensitive to noise. Obviously, it's on my slide. Okay, so it's based on single linkage clustering, which is very sensitive to noise. It's much more robust than that. That's a pretty simple algorithm. It's a way of detecting the number of clusters in a set of text data, or in this case, in a vector space, which is what I'm actually using it to cluster. And it has a way of identifying points that are like robust and meaningful versus those that are just noise in the model. Everything has noise, so here's a rigorous way to reduce it. It also doesn't require me to define the number of clusters. That's the virtue of hierarchical clustering. Yeah, also it works on a lot of different data sets. There's good literature saying this is really robust in some different domains. Okay, here's a picture. And moving on, kidding. Let's see, does this thing work? Yes. All right, so just trying to see if I can see it with you. Look at the orange. What do you notice about these points?
There aren't very many of them.
There aren't very many of them. What else?
They're orange.
They're orange, and they're together. Good job, Dana. That's the point. They're densely clustered, density. So in the lingo of this talk, they have a high coherence. This made-up cluster of orange points is highly coherent. You look at this cluster of light blue points, and it's kind of all over the place. Low coherence. The other thing is distinctiveness, which I'll just tell you. If you look at orange and compare it to, say, this teal green here, there's very little overlap. They're really occupying different kinds of space. High distinctiveness. Whereas you compare light blue and dark blue here, a lot of overlap, low distinctiveness. Anybody lost? Okay, moving on. So how do I do this? This is meant to be a method, so I want to really spell out to you what the workflow is. First, you got to train a model, and that's not a small task. So I'm assuming you have data and you trained it and you cleaned everything, which is very hard, and continues to take up a lot of my time. But then there's other things that you do too, and that's the whole point. First, you got to build your dictionary. All you need is a couple of core terms. You query the model. I mostly use model.mostSimilar in Word2Vec. It's pretty simple. And then you add some terms to this. This is a highly hand-curated process. You're looking for concepts that you, as the analyst, have some sense are related to the thing that you're interested in. So I started out with inquiry-based, discovery, and problem solving, and I was able to get 30 terms out of that. So, and you'll actually look at them in a moment. So querying, developing, it's an iterative process. You might add more terms. You might realize this is not getting at what I thought it was getting at. You start over. Okay, so but this is the basic part. You start with constructing the core dictionary. And then you refine it. And the goal here is to maximize coherence and distinctiveness. In my case, I've been working with 2 dictionaries. Other people often have 5. Moral Foundations is a theory, is a big application of this work right now. And they have 5. Right, so expanding and contracting. This is a bit more of an automated process. You can just say, take the most similar 100 words to your core dictionary of, say, 30, in my case 30. But then you find out, actually you'll see this in a moment, when the dictionary reaches a certain size, it starts decreasing in its distinctiveness from the other ones. And I'll show you some visuals on that, but that's the point. There's sort of some reasoning to happen in this stage, working with the model that shouldn't be as tightly hand curated, but yeah, that's the point, a bit more automated. Okay, and then based on what you find, you might realize, wow, these terms are not what I thought they were. I might have to revise the core dictionary, go back. So iterative process. The last thing you do is validate it. So you've got this big dictionary you built with the model, and the point is actually to use some other methods to reproduce what the model is saying. So I need to actually fill in the blanks here a little bit. So say you build the dictionary. In my case, I've got charter schools, and I just count the number of terms from the dictionary that occurs in a given school's website, right? From that, I produce a score from 0 to 1 of how inquiry-based or how disciplinary the school is. And the task is to reproduce that score, to make sure it's not made up. It's not just some artifact of something in the model. Okay, so there's another way you can do this. And since recurrent neural nets are pretty robust I would argue, I think is defensible, you can use that to build something else that isn't based just on your eyeballs and your sense of the literature and something you think you're looking for. And that's clustering. All right, so you can take these big dictionaries you built, and the first part is just cluster on them. Just take that, throw it in the clustering algorithm, in the word embedding model. They should all hang together. You should be able to see coherence in action in the clustering algorithm itself. You can also cluster the whole model. It takes a lot longer. Ours just finished. So I don't have good results to show you, really. And you can compare the clusters from the whole model, we found 391, to the dictionaries that you build. So I think I'll show you some more on that. And the very last thing you do, because it's very time-consuming and not as hard, is you, after iterating over and over again, of course, is to hand validate, which means to read a bunch of these, score them as high, medium, or low, for example, on these qualities that you're interested in, and then correlate that with the dictionary findings. Okay, so I'm going to walk you through these steps. In my example, how am I doing on time? Really? Yes. Wow, okay. Well, the workflow was the whole point, so I'm glad that's through. All right, so you start with a couple of words here. You load it into the model. This is the query step, right, part 1. You get a whole bunch of other words. Hopefully, intuitively to you, this makes sense. You're developing the dictionary by finding other words that are similar. Whole brain, language rich, project centered. Okay, that's there. And out of this, I get my core dictionaries of these 30 terms. I want to say something important here, and that's that the core dictionary for discipline is more theoretically oriented. I was looking for zero tolerance, no excuses, as well as some stuff about crime. These things have, they're related to each other, and I found them inductively by doing the, querying the model. But there's also some that I kind of forced in there because it's relevant in the literature. This one, inquiry-based, all these terms are very similar. It's a different language, we're talking about the same kind of thing. So child-centered versus student-centered versus inquiry-driven, the same people that care about one definitely care about the other. It's a fixed vocabulary, it's highly defined. So that's important for what we're going to see. The next thing you do, you refine it, starting with 30 terms, for instance, and going to 500. That's what I did. You've got the 2 dictionaries here. As you do that, you find that they become, if they started out being weaker, like I said, the disciplinary dictionary was less coherent and more theoretically driven. They actually get more coherent as you build it up. Whereas for ones that are highly clustered and have a tighter, richer, more defined vocabulary, the coherence doesn't really change that much. It oscillates a little bit because I think I cleaned the first one so densely. The other thing you find is that they become less distinct. And that's interesting because we want the dictionary to be applicable to different contexts, even when they have a slightly different application of these themes or concepts through their language. If I make it too big, I start losing something kind of conceptually sort of coherent. Okay, so the next thing, We validate. First you do the clustering, and then you do the hand coding. I just want to iterate that again, now to show you some data, and I only have a couple minutes. All right, so this is a clustering of my 2 core dictionaries. And the first thing you'll notice is that there's these 2 really nice bubbles. There's one here, and there's one there. And there they are. OK, so on the surface, that looks really good. But if you look closer, and hopefully you can see this, they've been shaded. They've been shaded by HTB scan, by the clustering algorithm. And the discipline core dictionary is not the full, the cluster that is shown for the core dictionary of discipline is less than the entire thing. In other words, like all the inquiry terms are tightly connected. The discipline terms, it turns out that disobedience, punishment, perpetration, and zero tolerance policy are somehow more central to the sort of the core meaning of what I'm looking at than is expulsion and suspension and discipline, the word discipline itself, which to me is surprising. So there's something in this. I need to actually revisit this. That's what this is telling me. Like, watch out, only half of your terms actually make sense. OK. Also, this reflects coherence scores. This one's much more coherent. But they do have a very high distinctiveness, which is good. Oh, I forgot to mention cosine similarity scores 0 to 1. 0 means the vectors are very different. 1 means they're pretty much parallel, the same. It's a measure of similarity in the vector space. All right, and then I tried this with the full dictionaries. And do you see any colors? Good news, no clusters. OK, so that means that there's actually, in my expanded dictionary, at least I didn't get too messy and capture something else that wasn't meant to be in there. That suggests that you can't really find anything better than this just being one big cluster. OK, same thing with the discipline dictionary. If you take both the dictionaries together, that's bad news, because they should be more distinct. Whereas if you color them, you notice that the blue and the pink, that's discipline, that's inquiry, kind of overlap quite a bit here in the middle. That's the reason why they're not clustering. They lost their distinctiveness. So what I'm trying to show you is these are different ways of getting at the same result. That's validation. OK, a couple takeaways. I'm not sure I have time to really go into this. Maybe you just want to ask me during lunch or something. But the longer you make the dictionary, the more coherent things tend to be, the less distinctive they tend to be. How many core terms? Diffuseness, that matters. OK. They seem to replicate each other. I don't know if hand coding will. It's iterative, so I have cleaner data, which means I'm starting over. You're welcome. And new dictionaries. OK. Some things that I need to build out of this that I think could be promising and useful to people are examining how these dictionaries actually apply. I don't know of a good tool to do that. So I just build these terms, and it's actually pretty expensive to count them over the whole corpus, which is annoying. So maybe there's some way to bootstrap that or make it build it into the dictionary generation process. OK, I'm done. Right. Right. So I need to look at the full clusters and see how they look in my dictionaries, and then maybe weight them. And that's just some details. OK, thanks for your attention. I don't have time for Q&A. Ask me later. Thank you.